All right, hello everyone. Welcome to this video. In this video, what I'm gonna do is that I'm going to teach you how to create your own blockchain using Python programming language. So the first thing that we're gonna do is create our own blockchain. The next thing that we're gonna do is we are basically going to write a server code in order to actually mine that block from the blockchain. So let's go ahead and let's start creating a blockchain. So for to understand this video, you need to have some understanding of blockchain and how that works. Okay, so how will I create a blockchain? I will basically create a class, and in that class, I will create several functions that will do all the stuff related to blockchain. So let's call a class as blockchain class. Now let's write a constructor function first of all, and the constructor function would not take any arguments. Inside of the construction function, I'm going to define what are the content of my block inside of my blockchain. So my blockchain will have a chain, of course, chain of blocks. It's gonna have number of transactions in each block. So of course I can also have a limit on the number of transactions on each block, but right now I'm just gonna say self.transactions equals to an empty array. And when I create a blockchain, I will also need to store nodes. So for now, I'm going to say that nodes not repeat the nodes. Now, the one more additional thing that I need to do when I create a new blockchain object from this blockchain class, and that is to create the first node. The first node is called, I don't know what it's called now. So there is a specific name to the first node in the blockchain. It's called Genesis block. So when I create a blockchain, I will need to create a Genesis block in the starting. So I will say that I'll later on write the function create block, where this function, let's say it's gonna take some arguments, but for now, let's just assume that this is going to create a Genesis block. Create a Genesis block. All right, so now this is pretty much it for the constructor function of our class. The next thing that I'm going to do is I'm going to write this function create block um, to create a new block in our blockchain. Now, a block contains information like previous hash, the index of the block, the timestamp, proof of work, and also the number of transactions and basically all the transactions that have been stored for that particular block. So when I create a block, I need to provide it with some information like previous hash and a proof of work. So inside of this function create block, I'm going to accept two arguments, which are going to be proof and previous hash. Now previous hash will be the hash of the previous block and proof will be the proof of work. So we need to provide these arguments when we create a Genesis block. In case of Genesis block, I will say that the proof is just 1. Otherwise, it has to be calculated using some hashing um, methods that we will see later on in the video. But right now, let's just say that the previous hash is 0. So in this way, my Genesis block will be created when I um, create the blockchain object. Now, inside of the create block function, I need to create a new block and then I have to append that block to the chain. And that's how a blockchain works. We create a new block with set of transactions and then append that block into the chain. So we are using Python dictionaries to create block for now. Dictionary has a key and a value. So for example, the index of the block is going to be basically the length of chain plus 1. Similarly, I need to have timestamp. Timestamp would be simply current date. So I can get the date from datetime function in Python. So let's quickly import datetime. This datetime function will give me the current datetime object, and then I can use that datetime object to create a timestamp for my block. Okay, the next thing that I'm gonna need is proof of work that was invested to create this particular block, and that's how blockchain makes sure that no two people can no single person can tamper with the entire list of transactions because we need a proof of work. So this proof will represent that proof of work. And the next thing that we need is previous hash. Previous hash is going to be previous hash. And the last thing that I am going to need is transactions. So this is going to contain all the transactions for this particular block. Now, I have created a block. This means I need to make sure that I remove all the transactions from my transaction array, because now whenever a new transaction will happen, it won't be appended to the already existing transactions. Instead, it will be appended to an empty array so that it can be put into a different block. I have created a block, so let's quickly go ahead and append the block into my chain. So this would be chain.append block, and I can return the block in case we need it. So that's pretty much it for the create block function. This function once again just creates a block from the proof of work and the previous hash, of course. So that's how you create a block. Now let's check what are the other things that we need. So inside of this create block function, we require proof of work, which means we have to write a function that can generate this proof of work. And then we also need to find a way to add transactions, add a new node, or maybe check if the chain is valid. So let's go ahead and let's write the function for proof of work first of all, because we need that function to create a new block first, and creating a new block would be our next step after adding some transactions. So when I go ahead and try to create a new proof of work, I will need a previous hash in order to make sure that the entire chain is valid and this additional block is not coming from a new chain. So I'll need previous hash. Now I'm going to create a proof. Proof is essentially a number. Um, it is also sometimes called as noance. So this number will basically append to my block and the previous hash, and all of that combined will create a new hash value. And that hash value is supposed to have some unique identity. And that unique identity could well as be having four zeros in the starting of the hash. That would be one way of generating proof of work. Now, uh, of course, hash functions are um, not decryptable, which means there's no actual way of getting to know the text that you need to hash in order to generate one particular ciphertext, other than just randomly guessing it. So we'll have to randomly guess until we satisfy the condition. Uh, and for our case, we will make the condition slightly easier so that we can run it pretty quickly. But I'll show you what will happen. Um, I'll show you what will happen if I make the condition really complex. In that case, our computer will take a lot of time to actually mine the block. So in Python, there's a library called hashlib, which we are going to use in order to we are going to use hashlib in order to compute the SHA-51, SHA-256 hash of our data. So let me just import hashlib right here. And now inside of this while loop, what I'm going to do is I'm going to um, get hash operations. I'm gonna say hash operation equals to hashlib.256, and inside of this I'm gonna provide some stuff like the new proof of work that I have, which is new proof to I can just write new proof to the power of 2 minus previous proof to the power of 2. I haven't in so this is supposed to be previous proof, not previous hash. So new proof minus all right, so to the power of 2, and then I'm going to simply encode that entire string, encode, and I'm gonna get the hex digest of this entire encoded string. So let me try to explain you what I'm doing here. What I have done essentially is just use the previous proof, created a new proof, and I have used the value new proof raised to the power of 2 minus previous proof raised to the power of 2, and then encoded it and passed it through SHA-256 hash function, and then and then got the hash digest for this. Now we can simply check if my hash operation has n number of zeros in the first n digit. So right now I'm just gonna say 4. So this is gonna be if this has 4 zeros. If this has 4 zeros, then we can simply say that I'm done, else I will improve my new proof value by adding 1 to it. And when this loop is over, I'm simply going to return a new proof. So this is simply guessing all the possibilities in order to reach our final state. Now the next thing that I'm going to do, now we know how to create a block. We also know how to do proof of work. So the next thing that we need to know is to add a transaction to the block. So adding a transaction is very straightforward. There isn't a crazy concept here. Adding a transaction is basically just we're gonna take sender, we're gonna take receiver, who's the sender, who's the receiver, and what's the amount. And this is pretty straightforward. What we're gonna do is inside of the transaction array that I have inside of my class, I'm going to append a dictionary with the key value sender to be sender, the receiver to be receiver, and amount to be amount, right? So this is really straightforward. So we have appended the transaction, and we are also going to increase the previous block. So we're going to say previous block is self.get previous block, or maybe since we haven't written the function, we're going to check what was the previous block, and then we are going to uh, return the index of that block, so that when I add a transaction, I know where have I added the particular transaction. And that would be really useful when I'm adding a new node, or when I'm adding a new node, because then when I'm adding a new node, I need to know where to add this node. So here we can simply maybe just say I can write a function. I can write a function here. The function would be get previous block. The get previous block would just contain it just return self dot chain of -1. This was our block, and here I can get the index as self dot get previous block. Now I have the index. I can just say return index +1. So that's how I've added a new transaction. Now the transaction has been added. Next thing that we would be doing is adding a new node. So we need to add a new node. We can do that. And we also have to now make sure that in case we have to check if our chain is valid or not, the chain of blocks that we have. And we need to do that because there might be cases when some person is mining our blockchain, and they are let's say they have added some fake transaction to the block, to the chain, and then we kept on doing it until uh, some person is trying to fake a new transaction into our system. So we need to make sure that we verify that the chain that we're receiving is actually valid. So we have to write functions for checking if the chain is valid. There are several different techniques to check if our chain is valid or not, but the one that we're going to use is pretty straightforward. Um, let's go ahead and check the let's go ahead and let's see what's the technique that we're going to use to check if our chain is valid or not. What we're going to do is we are going to loop over the entire chain that we have, and we are going to get a block, and then we are going to check if the proof that was attached to that block is actually um, stating that it has done the amount of work that is necessary according to the consensus algorithm. So what I'm saying right now is I will loop over my entire chain. I will go to a block, I will check the proof, and I will check if that proof is actually giving me this condition is being satisfied or not. Because if it is not satisfied, that means some person is trying to imitate the work by faking it, and I can simply check if the hash that I'm receiving after decoding that value has four zeros in the starting or not. If I don't have that, then I will return that this chain is invalid and the transaction that you just received no longer is valid. In that case, we will have to go and fix our chain, right? So in case our chain is not valid, what we'll have to do is we'll have to fix the chain, and there's going to be some uh, things that we need to do in order to fix the chain. And we'll get to that later on, but right now we'll just check if the chain is valid or not. Because if the chain is not valid, then we will check all the previous chains from other people, other nodes in our network, and we will choose whichever is the longest. Say that's the easiest um, approach to figuring out if the chain is valid or not, and then replacing it. So let's check if the chain is valid. So in order to check the chain is valid, I'm gonna create this variable previous block as the first or the genesis block in my chain. Now this is block index, which is it's starting from 1, and I'm gonna say while block index is less than length of chain. Till then, what you're gonna do is you're gonna get the current block as the block chain of block index. You're gonna check if block has previous hash. Block has previous hash. Um, if the previous hash of the block is not equal to the hash of the previous block. So we also do not have this hash function, but this hash function we'll write later on. What it's essentially going to do is it is going to take the block that I'm providing it, and then it is going to um, convert that block into JSON and then encode it and return it to us. Right here, yes, we are going to write this function self.hash. So this is define hash self comma block. What it's gonna do is it's gonna get the encoded block as json.terms block, and we're gonna sort it by keys. And of course we're gonna encode it. Now we haven't really imported JSON, so we need to import JSON. Now the next thing that I'm gonna do is I'm going to return the hash of this, which is this. So we are going to return the hash of the encoded block, and if that hash, so the previous block is simply the block that comes previous to the current block, and we are going to generate the hash of that block, and we're going to check if the hash of the previous block is not equal to the hash that is stored in the current block as the previous block's hash. Then we're going to say that this someone has messed up with the chain, so we're just going to return, oops, that's not what I meant to do. So we're going to return false, right? So once again, if I want to explain it to you in a slightly better way, then what I'm trying to do here is that every block has previous hash. Now I'm just checking if that previous hash is actually the previous hash. Okay, so that's pretty much it. Now I've checked this up. So next thing that I'm gonna do is I'm gonna get the um, previous proof, because I need that um, alongside my new proof in order to check if the work has actually been done. And so we're gonna take the proof as the current blocks proof. So now we have previous proof, current proof. Now we're going to do exactly the same thing that we did here. We're going to check this. So we are going to do hash operation, and if this is equal to this, then if this is not equal to this, then we can simply return false, and we say that the chain is totally invalid. Okay, so this is our new proof. I'm going to call it proof, and there you go. So uh, this is just going to return false. All right, so that's pretty much all. Now we have returned false. If we haven't, then I'm gonna update the previous block as the current block, and the loop goes on by increasing the block index by 1. If I have been able to check that for all the blocks, then I'm going to say that the chain is actually indeed valid, and the work has really been done on the chain, on the block. So that's pretty much it for checking if the chain is valid or not. And now, since we have written the functions to create a block, create the proof of work, then we have also written a function to check if the chain is valid. We have written a function to add a new transaction. The next thing that I want to do is I want to make sure that I'm able to add nodes and I'm able to replace chains. So those things will come later on. Right now, if I would try to explain to you how this nodes is actually going to work, it's gonna confuse you a little bit. So we will take a look at them later on when we are going to mine the blocks in our blockchain. So essentially, these nodes will be the chains. Um, so there, so let's try to understand it. Let me try to see if I can explain this using Jamboard. Let me open up a Jamboard quickly so that I can give you some understanding of what's happening here, because it's a really important um, it's a important piece of information. So now on the blackboard, what I'm going to do is, so let's say I have a chain, I have some blocks, I have a chain, and now I receive a new block. So I appended it in front of my chain, and then um, let's say, so this is one use case when I have a chain, uh, and I received a new block, so I add it into my chain. What are the other possible things that it might happen that I receive a new block, an entirely different block now, and that block says that block conflicts with the that block's previous hash conflicts, and the function, this is chain valid function, returns that the chain that I'm working on isn't valid at all. So in that case, I will need to revert back to the previous chain, right? I will need to revert back to the previous chain because this is creating conflict, which means the data that I had previously was conflicting. So I need to revert back to this chain. And how we do that essentially is by storing them in separate nodes. So every single person on the network is going to have node. Every single node will have a lot of chains, and the longest chain would be the valid chain. So what I essentially mean to do is that this nodes will contain a set of all the nodes in the network, and all of those nodes will have different chains. The largest chain would be the one that is valid. Okay, so we will have to write function to add a node into the network. By adding a node, I mean adding a new person who is going to use my blockchain. And there's going to be a function called replace chain, and that function is simply going to um, find out whichever chain is the longest, and then it's going to check if it is valid throughout, and then it is simply going to replace all the chains with the longest chain. So enough talking about the nodes and the chain. Let's now see let's now figure out how do I write the code to actually how do I write the code to so let me close this up real quick. Okay, now what we're gonna do is we're gonna figure out how to write the code in order to add a new node. So how to create a new node into our uh, blockchain. So we will do that in a second. Uh, just give me a second. I need to fix a couple of things. Okay, I'm back. So this is our blockchain. Our blockchain is complete for now. The next thing that I want to do is I want to create a Flask application. So in order to follow along, if you want to follow along right now, you would need to install Postman because we're going to create our API request to the Flask application through Postman. I have Postman installed already, so I can show you how to create API requests from Postman. But first, let's create let's create a Flask app. All right. Now, in order to create a Flask app, I need to import Flask. Flask, if you don't know about Flask, you can check it out on the official documentation of Flask. It's pretty straightforward. So these are the libraries that I have imported in order to create our Flask application for now. So let's create the app. App is nothing but Flask underscore underscore name underscore underscore. Now there is something that I specifically want to focus on, which is that whenever I make a request to the network, I want to have several different nodes which can access our network. And in order to have several different nodes, hmm, I need to have a different node address for all of them. Uh, So I'm going to create node address. Now you can of course create a random node address using some other library that you like that can generate random strings. But for us, we're just going to use UUID to import the latest version of UUID, which is UUID 4, not 3. So our node address is basically, we can say it's a string. I'm gonna call UUID.4. Now this UUID thing creates a UUID having a dash sign, which we do not want in our address. So we're just gonna remove it, and now it's gonna be a straightforward random number, random string with digits and everything inside of it without any special character. So that's a node address for now. We're also going to create a blockchain instance, which is going to be the object of our class. Now, remember when we create object of a class, the constructor function would run automatically and it is going to create a Genesis block. So a Genesis block has been created as a Genesis block would be created as I start up my application Flask APK. Um, so now we can write several routes to access our blockchain network. So let's think about it. How many routes do we need, and what are the type of routes that we need in our network? So we will need a route to add a transaction. Definitely, we need to check if the transaction or the blockchain is actually valid. Um, we also might need to have a route to mine the block, because someone has to do the work in order for the block to get admitted to the chain. Someone has to attach a proof of work, and now that proof of work can't be always attached by me only, because if I do that, then it would be very costly and not everyone would be able to access my network because of the computational requirements of creating a proof of work. So to make sure that that happens, we are going to create a separate route to mine a block. So let's just start by um, uh, writing the route for mining a block. So this is gonna be app.route main block mine block. I'm gonna call it mine block. So now you can mine a block. Get it's a get request. In Flask, we create functions for all requests, and those functions will actually take care of, and those functions will run whenever someone hits that URL with the appropriate method. So mine block will have we will need previous block in order to mine a new block, because we will need several things from that previous block, which you should be able to guess until now, because I've already talked about it like twice. We have already checked that when we were checking the validity of a chain. So we need the previous proof of work. We need the previous proof of work from the previous block, uh, and we are going to get the current proof of work from blockchain dot. So we are going to create a proof of work from blockchain dot proof of work. The function proof of work basically randomly guesses until it satisfies my consensus algorithm. So for now, it's just gonna be proof of work of previous proof. So now I have a new proof. So the next thing that I would do is I would add the transaction, because I'm mining a block. So in order to add the transaction, I also need to know what was the previous hash value. The previous hash value could be extracted from the hash of the previous block. I have a function called get previous hash, which is this is get previous block. Do I have a function to get previous hash value? I have a function to get previous hash value. So I'm just gonna write blockchain dot hash previous block. Now I have a previous hash value. Now this previous hash value is really important, because we are going to add a new transaction, and adding a new transaction will require us to have sender. Sender is going to be the node address that I just created for this particular node. Receiver, let's just say the receiver is some random person for now. Let's say it's me, and let's say right now we're just interested in one unit of currency. Of course, we can get these values like receiver and the amount from the app route. So in that case, it won't be a get request. It will be modified to a post request, and I will have to send these through the API request, and then I can add them in this function right here. But I'm not interested in that, because that's not relevant to our use case. We just need to, we're just trying to show how we can create our own blockchain using Python. And now I'm going to create a block, creating a block from proof and the previous hash that we have extracted. Now we have a block created, so we can simply return the response. return JSONify of some string and the status code 200. So let's see what do we want to return as a response. Because we want to read the response in Postman, I'm going to return several interesting things here. I'm going to say message is congrats. I'm going to return an index so that we can check how it is actually being implemented. Here I also want to have timestamp. Timestamp can be extracted from the block itself once again. Um, and I can have proof, maybe block of proof. What else do I want to see? Yeah, I want to see what is the previous hash. I can get that from this, and I also want to check what are the transactions of the inside of this block. So I'm going to say block of transactions. That's pretty much all. This is purely optional. In an actual network, these things are not returned. But in our use case, since we are trying to understand blockchain, it's fine if we return all of this. So now that's how you're going to mine a block. So that's pretty much all about mining the block. Um, Now we are going to write one function, which is add transactions. App.route add transaction. The method is going to be post method. I'm going to say add transaction. So the transaction could be added using, so I'm going to get the transaction from the request. So I'm going to say JS equals to, or maybe JSON equals to request dot get JSON, and I'm going to have one array storing all the transaction keys, so sender, receiver, and the amount. Now I'm gonna check if all of this is, all of the keys are in JSON. All of the keys are in JSON. If they are, if that's not the case, then I'm gonna say failed with a status code of 400 because it was a bad request. Otherwise, I can simply get the index of that particular thing. I can say add transaction, and I have everything inside of my JSON. Sender, JSON of receiver, and JSON of amount. Uh, and I'm gonna create a response. The response could be index. Index is gonna be the index, and I'm gonna return JSONify response, comma 200. So here's the thing. Um, when I mine a block, I add a transaction that the miner will receive one amount of currency from this person Tarun, which is not real, um, because they are generating the proof of work, right? So they will receive some amount from the network, okay? And this add transaction will add the transaction to our blockchain. Uh, Now that's pretty much it that I wanted to write for now. Is there anything? Let me think if I want to add something else. Um, yeah, maybe I want to add. Uh, I also need to add another route that can create that can connect a node. So I'm gonna say connect a node method is gonna be post um, code is going to be connect node. So once again, I'm going to get all the information from the request, and I'm going to check if this is there, and then if there was no nodes until now, then I'm gonna say none comma 400. Else if that's not the case, then I'm gonna add all the nodes to my blockchain, and this is gonna be blockchain dot add node of node. I haven't written the add node function, if you remember. um, and then I can simply say done with a status code of 200. So that's how I can connect the road. Let's quickly run the app that we have created. Let's host it on 0, 0, 0, 0 and port. So this is how I have created my blockchain right now. Yes, I haven't written several functions like add node for now. So maybe I just want to comment it out for now. Let's save it and let's try to run the app. It says the method mine block is creating some problem. So let's see, where is mine block? Mine block is here. It says inside of the mine block it is creating some problem because got an expected keyword called method. uh yes, this is supposed to be methods, not method. Okay, now let's try and run this. Okay, so the app is now running here. So if I go right here and I go to my Postman, I create a new request. Um, so for example, I can create a post request to add some transaction. So I'm going to create a post request to this slash add transaction. I also need to have I need to provide some information to this in form of JSON. So I will do that. I need a sender, receiver, and amount. So I'm gonna say sender is person one, my receiver is person two, and the amount that I'm sending is 23. Now if I hit this, I should have got the correct thing, but I haven't because it says there are some problems. Line number 57 in add transaction. Did we do something wrong? We got the previous block returned this. Oh, wow. Of we need to get the index of the previous block, so we have to write index here. Now I have to restart the server. This happens with Flask all the time. Alright, so now we have added one block and the index of the block has come out to be 2. Uh, maybe it would be really interesting if we write another route that can return us the entire chain, because I want to see what is the entire chain, what does the entire chain has. So we're gonna write this function that will return us the entire chain. It is a get method, um, simple function get chain. All it's gonna do is return JSONify dot blockchain dot chain, right, and 200. So this is going to return all the complete entire chain that we have. So let's also create another request. This is going to be a get request to um, get the chain. So I'm going to make a request to get chain. Let's send. So currently we just have the Genesis block with the index as 1, previous hash as 0, proof 1, and these are the transactions. Now if I add a new transaction, if I then do get chain, my chain should have updated itself, but it hasn't. So there is something that if I add another one, I'm still getting index 2, which means my block hasn't really been added because I made some mistake. What mistake did I make? Let's think about it for a second. I have to add a transaction. I said add a new transaction. Oh, that's because I have added a transaction, but I haven't really mined the block. And until I mine the block, it won't be added because there's no proof of work. So I'm just gonna copy this real quick. I'm gonna write it here. I'm gonna make a post request and I'm gonna make a request to mine block. It is a get request. It's not a post request. Yes. When I mine the block, I see that all the transactions that were added to the chain that I have. So the block number 2, I added 3 transactions, or actually a lot of transactions, a lot more than 3. Now all of those transactions have been mined. All of those transactions have been added to the chain, and chain has been mined. So you see, I've added this person 1, person 2 transactions. I've also had something like amount 1, which is basically the which basically means that the miner has got something in return for the proof of work. And now if I get the chain, I will get one extra block here. Okay, so I can add another block. If I say right now, I'm gonna say someone, this is gonna be someone else, and this is gonna be one. So now in this case, what I want to do is I just want to add one transaction, and then I want to mine the block. So I added a transaction to the block number 3, and remember, we just have one transaction in this block, and the other transaction would be the money that would go to the miner. So now if I mine the block, we see that we have 2 transactions in the new block. One is the transaction that I added, another one is the money that I got, and now the chain has length 3. It has length equal to 3. So this is pretty much it. We have created our simple blockchain using this. Now there are some things that I didn't talk about, though I said that I will, which is that I will create multiple nodes and try to show you how having multiple nodes, there could be a case where some chain becomes invalid, and in that case you can use this function is chain valid to check if the chain is invalid, and then you have to write another function to sort of uh, modify the chains of all the nodes with the longest chain that you have in the network. So this will help you make sure that all the data that you have in your network is consistent, and that's really important. So but I said I would be doing that, but I do not have enough time to do that because I have to rush back to do some other work. So I think this is enough for today, and that's how you can create your own blockchain, mine it, and learn about it and have fun with it. So that's pretty much all from my side, and I'll see you tomorrow.